Welcome to Pomodoro Joe for Tuesday, August 29th, 2023. Today we're doing LeetCode problem 2483, minimum penalty for a shop. This is a medium problem. You are given the customer visit log of a shop represented by a zero-indexed string, customers, consisting of only characters capital N and capital Y. If the ith character is a capital Y, it means that customers come at the ith hour, whereas a capital N indicates that no customers come at the ith hour. If the shop closes at the jth hour, somewhere between 0 and n, the penalty is calculated as follows. For every hour when the shop is open and no customers come, the penalty is increased by 1. For every hour that the shop is closed and customers do come, the penalty is increased by 1. Return the earliest hour at which the shop must be closed to incur a minimum penalty. Note that if the shop closes at the jth hour, it means the shop is closed at the hour j. All right, that's kind of complicated, but they've got an example here. So our customers is a string. Yes, yes, no, yes. So the output is 2. So why is the output 2? So if they close the shop at the 0th hour, it incurs a penalty of 3 because it closes here and there were 3 Ys. So we were closed, but there were 3 hours where customers arrived, so we have 3 penalty. All right, if you close at the 2nd hour, let's see, we stayed open for the 1st hour, but there's a penalty of 2, okay? If you close at the 3rd hour, it incurs a penalty of 1 because we closed when there weren't any customers, but we had one customer arrive or some customers arrive in the next hour. So we incur a penalty of 1. All right, so we incur a penalty of 1. And then this is the 3rd hour, index 3. And it looks like there's the 4th hour. So we can actually close after all of our hours here. Interesting. And that also incurs a penalty of 1. Interesting. Closing the shop at the 2nd or 4th hour gives the minimum penalty. Since 2 is earlier, the optimal closing time is 2. I see. So we choose the earliest possible hour we can close with the minimum penalty. All right, so let's put 25 minutes on our Pomodoro timer and we will get started. So let's see, there are a couple different ways we can do this. The first way that comes to mind is just the brute force approach. We just go through every single hour, calculate the cost or the penalty for that hour. If we close on that hour, what's the penalty we'll incur? We just find the minimum penalty. We might have to store these in an array because let's see, we need to find the minimum penalty, but we also have to find the earliest minimum penalty. I guess we don't need an array. We could just keep track of what the best penalty is so far. And if we have a smaller penalty, then that becomes our new penalty. Okay. That wouldn't be too bad, but calculating this cost or this penalty for closing early. So if you calculate the penalty for closing at hour 0, that's basically all the future hours where customers did arrive. So we have to go through every hour from 0 to the end. Then calculating the penalty for 1, again, that's all the future. So we have to look at all the hours from 1 to the end. So we'll be recalculating these over and over and over again. So it might be better to go from the end of the day backwards to calculate our penalty. So if you go at the end of the day and you work backwards, you can look at what's our penalty for closing on the last hour? What's our penalty for closing on the second to last hour? Well, that's whatever is at the second to last hour plus the penalty for closing on the last hour. All right, so I think that's what we'll do. I think we'll calculate the penalty for the entire day and then work our way backwards. So we could just work our way backwards, but the penalty for, let's just choose some index. Let's say this index here. The penalty for closing at this index, which is index 2. That is the penalty for being closed at all future indices and plus the penalty for being open before this index. So if there are a bunch of n's in this case, so our penalty for closing at a given index is the sum of the penalty for being closed for every hour after that index, including that index, plus the sum of the penalty for being open before that index. Okay, so I think what I'll do is sort of a hybrid approach. Let's actually calculate what is the maximum penalty we'll pay for just being open all day. So we'll just say, what's the cost that we'll pay, or the penalty we'll pay for just staying open all day? Whatever that penalty is, that will be our baseline penalty. Then we'll go backwards in our list and say, well, what if we closed on the last hour? What's the penalty then? Well, if the last hour is a Y, then we'll actually be paying an additional penalty because we closed at this hour. So our new penalty will be that base penalty plus one more penalty because we closed early. Now, if this is an N, then we don't add anything to our penalty because our penalty was already paid for being open during that time. And in fact, we could remove one from our penalty because if we closed and no customers arrived, we had paid the penalty in our base penalty, thinking that we would be open. But if we close, we can actually reduce our penalty by 1. All right, this might not make a ton of sense, but let's get into coding and see how it goes. So let's see, what will I need for this? Well, I'll need a base penalty. So this is the penalty for staying open all day. Let me just write that down. All right, so that's our base penalty. Now we'll just go through and we'll calculate our base penalty. So for every customer in our customers, if the customer is not there, there's no customers on this hour, then we actually have to pay the price for no customers arriving and the store is open. So our base penalty will increase. Okay, now we've got our base penalty calculated. What's next? Well, now let's start closing the store 1 hour earlier for each time through our loop. Calculate our new penalty. Based on our new penalty, we could find out, well, what's our result? So let's see, we'll need some result. And we'll start at, well, let's see, we'll need to know how many hours we can be open. Let's have hours. That's going to be the length of our customers. All right, so that's how many hours that we can be open. So our result, we're going to start at hours because that is our base penalties index. Okay, so currently, if we closed at the end of the day, we have our base penalty for staying open all day, and we closed at this hour. All right, what else do we need? Well, we need to know what's our best penalty so far. And right now, that's just our base penalty. And then we also need to keep track of our current penalty because we'll be closing the store 1 hour earlier each time through our loop, and we'll have to keep track of our current penalty. And let's see, that's going to be our base penalty to start with. Okay, so I think this gives us our basics. Now, let's start closing the store earlier. Okay. So now this, I'm actually going through my hours backwards, which is going to be a little tricky, but with Python, there's some tricks with this. So for every hour in our range, now let's see, I'm going from our last hour index, which is hour -1. So that's the last index. And we're going all the way down to 0. So because it's not inclusive, we have to go to -1. So this will take us to 0, but not past 0. And we're going by steps of -1. Okay, so this will take us from our max index, hours -1, down to 0, including 0, with steps of -1. All right, so now if the customer's at this hour, let's see, if they are equal to yes, that means customers did arrive. Then if we close on this hour, our penalty actually increases. Okay, so we're assuming now we're closing at this new hour, H. If we close at that hour and customers did arrive, that means our current penalty will increase. Previously, we had been opened, so that Y is already built into our base penalty. Now we're closing, so our current penalty actually gets increased by 1. Otherwise, if this is a no, meaning no customers arrived and we closed on this hour, our base penalty had already assumed that we were open on this hour and included that. So our base penalty can decrease by 1, or actually in this case, our current penalty will decrease by 1. Okay, so now we're going back in time, closing our store 1 hour earlier each time. If we had customers arrive and we had just closed, we're going to pay an extra penalty for that. If we don't have any customers arrived and previously we had calculated the penalty for being open, now we're closing, that means we can reduce our penalty by 1 because we closed and no customers arrived. Okay, now if our current penalty, this is our new current penalty, if this is less than our best penalty so far, that means we found a new, better penalty. So at this point, our result can equal this hour, and our new penalty, our new best penalty, will be this current penalty. Awesome. Now let's see. This did say we need to find the earliest hour. So if we found a new current penalty that's the same as the best penalty and we're going backwards in time, we actually found an earlier hour which we can close. So I think we actually need a current penalty less than or equal to our best penalty. And now at the very end, we can just return our result. All right, let's try this out, see how it goes. It seems to work. Let's see if we can pass all the tests. And we pass. Let's see, we do all right. We beat 73% for runtime and 72% for memory, so that's not too bad. And we can jump in here and see how other people do it if we want. I'm just like jumping to the top here. Oh, interesting. So they're doing this a little bit differently. Looks like they're going forward in time, keeping track of, it's very similar though. They have a min penalty starting at 0. They're going to be doing the same thing that we were doing, but calculating going forward in time. And let's see, if the current penalty is less than the minimum penalty, then our answer becomes this new I. Okay, that's pretty interesting. So they're doing something very similar to us. They're just going forward in time, which I guess we could have done. It just seemed to make more sense to me to go backwards in time. All right, well, I don't have a ton of time today, so I think that is it for me. You should check this one out. It's an interesting thought experiment. So I hope you enjoyed this, hope you had fun, hope you learned something, hope you can go out and write better code.